What is the area and circumference of a circle? What's the area of a circle? That's how many degrees. What's the area of a circle?
Like the equation?
Yeah. Pi times r squared. That's the area of a circle. You're writing this down for your review because you're going to need it today. And remember, this is the center. From the center to the edge of the circle, that's your radius. What's the circumference? Two times pi times r, or diameter times pi. Today we're really going to be using the radius, okay? We're short on time. We did the nets, so we're going to scratch this for now. We did the folding with the nets. We also looked at that yesterday. So today when we get into cylinders, we're going to need to use the area of a circle. Ready? It says popcorn, anyone. Are you ready? We're going to read it together. Today we'll make popcorn containers out of paper. First, we're going to fold the white paper as shown. Are you ready? I'm just giving you scrap paper. You and your partner. We're going to record the dimensions. We all started with an 8.5 by 11 piece of paper. It's just a standard piece of paper. So the height, how tall is this? 11. It's 11. Oh, man. How do I get the width? What was this width made up of? Divided by 4. And our width originally was 8.5. So right now, 8.5 divided by 4. So we get 2.125. What about the length then? The length and the width, do you see how they're equal on this? If you look at this face, the length and the width are going to be equal. And how did we get that? We just took our total width, 8.5, divided it by 4. Our length and our width are equal. Are we okay with this? Great. Put that one to the side. Right now I'm going to hand you a colored piece of paper. The person who folded the last one, you're folding now. Here we go. So let's talk through the dimensions. How tall is your yellow piece of paper?
8.5 inches.
8.5 inches. So then what is the length and the width? They're going to be equal. We're looking at this face. What is the length and the width? How do we get that? What do you think, Amelia?
Is it the same thing as last time? You just do 11 divided by 4?
Yes, exactly. It's the same thing as last time, but I'm going to take 11 and divide it by 4. 11 divided by 4, we get 2.75, and the length and the width are equal on these rectangular prisms. Whoa. So again, my question is, if I compare these two, which one do you want to get popcorn in at the movie theaters? The second one? Do you think you're going to get more volume?
No, but you can put your hand in it.
But you can put your hand in it. It might be easier to eat out of. Okay. Flip your page. Here we go. Next. Which of these containers has a greater surface area? Which of these containers has a greater surface area? What do you think?
Well, I wanted to say they were the same.
You're right. They are the same. Oh, man. They're the same. Why are they the same surface area? We took the same size paper and just folded it two different ways. Oh my gosh. They're the same. They're the same. We took the same size piece of paper, but folded it the same different ways. So we have the same size piece of paper. It's just folded differently. That's all that's going on. problem 4 and 5. They want us to calculate how much surface area would I need to make a top and the bottom for prism A? How can I figure out this area? What is this shape? A square. And what was our length and width for prism A?
2.125.
Okay, so what am I going to do? To find the area of that square. Times them. What do we get? Should get about 4.15 inches squared, but that's one square. So what do I have to do one more time? That's one square. I want a top and the bottom. Now what? Do it again. We're going to times that by 2. We get 9.02 inches squared is the top and the bottom. Right now, I want you and your partner to do the same thing for 5, but look back. What were the dimensions for 5? Lots of papers today. Now we're going to roll paper. All right, we've got cylinder A made. We're going to start filling out the chart here. How tall is cylinder A? Well, it's 11 inches. Whoops. 11 inches. And now I need to find the radius, guys. I do know the circumference equation. I need to find the radius. How does this help me? Do I know anything about the circumference? What's the circumference? What side of the paper did you roll up? What?
8.5.
8.5. So I know circumference is 8.5. You're writing this down. I know the circumference is 8.5 because I rolled the piece of paper together and this 8.5, the short side, was our C, our circumference. Are we visualizing that? Are we okay with that? And now we're going to solve for R. We're going to do some algebra. How do I get R by itself? Get rid of the 2 pi. How do I undo multiplication? Divide. So you do need your calculator. In your calculator, you're going to do 8.5 divided by 2 pi. And what do we get? It's going to be a decimal. It's going to be okay. What do we get? 13? That seems a little high. 8.5 divided by 2 pi. It's going to be a smaller decimal. It's going to be a smaller number. 8.5 divided by 2 pi. What's happening? Hold on. 8.5. I think it's because of the PEMDAS. 2 pi. That's better. Yeah, we got to put parentheses.
I still got 13.3.
I got 1.35. Our radius is 1.35. Earlier we got 13, but that didn't make sense when we're looking at our cylinder. Our circumference is, we already talked about that. What's our circumference? All the way around. 8.5. Are you ready? Now we're going to take a blue piece of paper and we're going to fold it the other way and talk about the parts of the cylinder. Here we go. Here's cylinder B. How tall is cylinder B?
It's
8.5.
Oh, good. 8.5. And what's the circumference this time on circular B? 11. And now we just got to figure out the radius. What equation am I going to use to find the radius?
11 divided by 2 pi.
11 divided by 2 pi. We know circumference is 2 pi r. We know that our circumference is 11, so we'll divide both sides by 2 pi. So our radius, when we type this in our calculator, you do need parentheses. 11 divided by 2 pi. You got 1.75. Does that make sense? If you look at your cylinder, does that make sense? The radius of 1.75 fits in there? Great. Are we catching on to the different pieces? For a cylinder, you're going to have a height. You're going to have a radius to find surface area. What are we missing on our cylinders here?
Bottom.
Bottom and top. And what are the bottom and top?
A circle.
A circle. So we're going to have to use the area of a circle here in just a minute. We got our table filled out. How is the circumference of the base related to the dimensions of the paper? The circumference is what?
The width.
It's the length. Is the length of each paper. So our length on this first one, 8.5, was 11 on the second one. Number 9. Scott did his experiment with a different size paper. His cylinder container had a radius of R and a height of H. What are the dimensions of the paper in terms of R and H? Well, your length is going to be the circumference, 2 pi R. And your width, our width is our height, became our height. Number 10 is going to ask us to imagine adding lids. I think you already answered this for me. If I add lids, what shape are they? Circles. So guess what? Last thing we got to do. We got to find the top and the bottom and add it. So let's do it. Are you ready for 10? Is anyone still writing? 10. Imagine you created lids for the top and bottom of each cylinder. What would the total surface area of cylinder A and cylinder B be, greater or smaller? Let's just find the surface areas. So first off, let's go back to our table. In our table, you've got the circumference and height. So I really want you to start imagining that to find the area of this paper, what would I do? What would I do to find the area of that paper? It's a rectangle, right? How to find the area of a rectangle? Length times width. Okay, in this case, our length and our width are going to be the same. So we're just going to find the area, the surface area of cylinder A. For cylinder A, we're going to do length times width of the rectangle. So 8.5 times 11. And then I'm going to add 2 what? I unfolded it. It's a piece of paper. And then I want to add a top and the bottom. And they are 2 circles. And I know the radius from cylinder A was 1.35. So I'm going to do 1.35 squared times pi. And I'm going to times that by 2 to represent the top and the bottom. So right now with your partner, I want you to figure out what's the total surface area for cylinder A. So you're doing the rectangle plus the 2 circles. What's our total surface area? All we're doing is the rectangle plus the 2 circles. Check your answers. I got 93.5 for the rectangle part. When I did pi times 1.35 squared, I times my answer by 2 and I got 11.45 for both circles, the top and the bottom. Did you do that in your calculator? I'm going through area of a circle quickly because we just spent 2 units on circles. So we add this together, we should get our total surface area. 93.5 plus 11.45. I get a total surface area for cylinder A is 104.95. We're going to say inches squared for surface area. How'd it go?
Not too bad.
Okay, let's summarize what we did here. I'm going to give you two equations to find the area, the surface area of rectangular prisms and cylinders to make your life easier. Are you ready? Can I move on to the next page? Here we go. A rectangular prism. A rectangular prism. I'm going to draw a net. So sketch a net with me. Oh man. We'll try this again. Sketch a net as best as possible. Boom, boom. I'm so serious. We're sketching a net. Great. This is your length. This is your width. This is your height. Again, this is a rectangular prism. I'm going to give you a basic formula for this. Are you ready? Basic formula. You should notice that you have two of each rectangle. You should have two of each rectangle. So I'm going to do 2 times the length and width plus 2 times the height times width plus 2 times the height times length. That should always get you the surface area of a rectangular prism. Even if the length, width, and height are different, that is the surface area formula for a rectangular prism. Here's the surface area formula for a cylinder. First, I'm going to sketch the net. Do we agree that the net is a rectangle and 2 circles attached? Do we agree? That's a net if I unrolled this, and this is for a cylinder. So first, sketch it. This is for a cylinder. We've got 2 circles and a rectangle, and we call the rectangle the lateral surface. Can you write the lateral there? It's the lateral surface. And you've got a circle here and a circle here. Our equation for the surface area, we just talked through this. It's going to be 2 of the circles plus the area of that rectangle. The area of that rectangle. What is the length of this rectangle? We just talked about it. What's the length of that rectangle? Start with the C. It's the circumference. So I'm going to add the circumference, and I'm going to times it by what? If I were to unfold this paper, I would times it by the height of the cylinder. Height. So sorry, that's a little squished here. The surface area formula is 2 circles plus the area of that rectangle. The area of that rectangle is going to be circumference times the height. So this side is the height of the cylinder. This is the circumference of the cylinder. Okay.